Hello, everyone. I already start with the introduction. Maybe other people will join. So welcome to another CIF seminar. After this one, there will only be one left in 2020. And today I have the pleasure to introduce to you our speaker, Dr. Sion. He is a postdoctoral researcher at Distrinet, and Laurens defended his PhD on automated threat analysis for security and privacy almost 1 month ago. His research interests are threat modeling, privacy by design, and today he will share his insights on privacy by design with us. After the talk of Laurens, there will be room for questions and debate as usual. And also, as usual, please be aware that this presentation and the questions afterwards are being recorded. And you find the recording afterwards and the slides on our website, which is certainly worth a visit because we've already announced some exciting topics that will be discussed in 2021. You can visit our website if you want to. And okay, I think this is everything I have to say. So Laurens, the floor is yours.
Thank you, Sophie, and thank you for the introduction. So I hope everyone can see my slides.
Yes,
and can hear me. Okay, great. So today I will be presenting DPMF, a modeling framework for data protection by design. Before I go into the details of this, I want to start by saying that what I will be presenting today is the result of a lot of joint work with many different people in the context of the PRICE project on privacy by design regulation in software engineering. And this, of course, would not be possible without the inputs and contributions of all these people. And it's a joint work both at Distrinet and at CIF. So let's have a look at why data protection by design is important and why we need to spend effort in considering this when we design and develop software systems. So one type of pressure is, of course, the number of data breaches, which we see frequently reported in the media, and there's a steady increase in the number of data breaches that get publicly reported, and not only in the number of breaches that we actually see being reported, but also in the amount of data that is exposed in these different breaches, and especially the sensitivity of the data that is exposed here. So this is an important incentive and forces us to take the privacy and security of our software systems very seriously.
Laurens, you're still on the first slide on my view.
Oh.
I don't know if anyone else sees it differently, but I see the first slide, your title slide.
I can try to... You're on slide 4.
Yeah, I see slide 4. So
yeah. Yeah, I'm on 4, so it looks to be a local problem.
Okay, go on.
Okay, I will continue then. So a second pressure here is, of course, regulatory pressure, and a great example of that is, of course, the GDPR, which many of you will probably already be familiar. Probably because you have to click a lot of consent banners on all the different websites that you visit. So it's a nice illustration of a far-reaching impact of this legislation. And the GDPR actually requires us to take data protection into account and to do this by design and by default, and it requires us to implement appropriate measures. So this is also an important pressure, especially with the large fines that can be that you can get as an organization if you violate some of its provisions. So it's also an important consideration and pressure to take into account the security and privacy of your systems when you design and develop them. So let's go into a bit more detail about what data protection by design specifically entails and what they expect us to do in the design and development of our software systems. And there are actually 5 key components that are listed and that we have to do when we set up and run our data processing operations. So the first one is that we have to consider the risk to data subject rights and freedoms. So when we process data, we have to consider what the impact is of these types of processing operations on the data subjects, the people whose data we are processing. And that requires considering the type of data subject. For example, if we are processing data from children, but also the sensitivity of the data and what we are doing with it. So these are important factors that we have to consider throughout our data processing operations. Secondly, of course, we have to ensure compliance with the different requirements that are laid out in the GDPR. So there are several restrictions and checks and assessments that we have to perform that are detailed, and we have to meet all these obligations. A third component is that we have to apply and implement appropriate measures. Now, these are both technical and organizational measures. So that can be things like encryption in our software system or anonymization, but also organizational measures at the level of the organization itself that is processing and setting up the data processing operations. Now, what is an appropriate measure? Well, this also links back again to the risk component, the first one that I mentioned, because of course, if we are processing very sensitive data, or if we're processing data of children, that requires us to apply more strict measures if the risk is higher in these instances. Then a fourth component is demonstrability. So we not only ensuring compliance with the rules, but we actually must also be able to demonstrate that we meet the different obligations from the GDPR. So when a national supervisory authority comes knocking on the door and asks us to give them our records of processing activities, what we are processing and what we are doing to make sure that these processing operations happen safely and protect the privacy, we need to be able to provide this documentation to demonstrate that we are compliant. And finally, a fifth component is when we have to do all of this, and this requires us to do this both when we are determining the means of the processing and during the processing itself. So it's not sufficient to just afterwards, when we are processing, to apply some measures, but we actually have to consider this from the start. So even before we are processing information and when we are thinking about our data processing operations and designing it and laying out how we are going to do it, from that point on already we need to consider the impact on the data subject and make sure that we apply appropriate measures throughout to protect the privacy of the people whose data we are processing. So how are we going to realize all these different obligations of the GDPR? Well, we start here from the perspective that we want to apply a data protection impact assessment. Doing such an assessment is actually mandatory when there's a high risk to data subjects' rights and freedoms. So there are several instances where you actually have to perform such an impact assessment. But even if it's not mandatory, it's quite a useful tool because you have a very systematic and comprehensive analysis of your data processing operations, and a lot of the effort that you do is actually shared in regardless of whether you do an actual DPIA or not. So it's in any case very useful to apply a DPIA. So before we zoom into a bit more detail in the approach that we take in tackling this problem, let's have a brief look at what are some of the existing approaches available to support us in doing such an assessment. So I have a few of them, and I will go into a bit more detail in what they offer and what the problems are. So the first one are templates and questionnaires. So these are mainly the tools that are provided by many of the national supervisory authorities in the different countries. So I have some examples here from the Belgian authority and from the French one. So these approaches mainly focus on templates and structuring and providing a very detailed description of your processing operations and your data types. So it's mostly descriptive, these different approaches. So you will result with a lot of documents describing your processing operations. Now the problem is that they don't provide a lot of support for doing a very extensive assessment or analysis. That still requires considerable effort. And another downside in these approaches is, especially when you make some modifications, if you have your operations described in different documents and different spreadsheets, it becomes very complicated when you make some changes to ensure that the whole actually still is a consistent description of your data processing operations. So it becomes also difficult and complex to manage all this information and to make sure that everything is still consistently and accurately described. A second set of approaches starts more from a software engineering perspective, where they look at introducing some extensions to existing software design models. More specifically, they add some stereotypes to UML, for example. And what this allows us to do is to include some additional information, such as whether we're processing sensitive data or what the objective is of a certain method in our software program. For example, in this case, marketing, as you can see in the illustration. And this gives us some additional information to work with and to perform certain types of assessments. The problem with these approaches is that your base model or representation that you use is the software design model, and this does not contain all the relevant concepts that are useful or necessary for performing a number of legal assessments. So, for example, the organization that is actually that has the role of controller in your data processing operations, so that applies a number of legal obligations, and this organization is actually not represented in your software design. It's an organization and it's not a component in your software product. So you will not find this organization anywhere in the software design model, and you will not be able to use this information in your analysis. Related approach or privacy and security requirements engineering techniques such as security and privacy threat modeling. These also rely on a similar description of software system, in this case a data flow diagram. So that's a very high level view of what the processes are in your system and which where you store data and with which external entities that you interact. But here you have a similar problem. So you can systematically analyze this representation and try to identify all cases where you process data and then raise the issue, is this automated decision making, for example, but you don't have a lot of extra information to work with. So in this case, the person that gets that large list of issues that are identified will still have a lot of manual effort to do to determine whether this is actually a relevant issue or not, because you're missing a lot of additional legal information that's not really present in these types of diagrams. So they suffer from a similar problem as the other software design models. So with that brief introduction of the existing approaches that we have available to describe and realize data protection by design, or a data protection impact assessment more specifically, let's have a look at what our approach is towards tackling this problem. So the key observation that we start from is that we see that different types of stakeholders have actually substantially different views to reason about the system or the data processing operations that they are describing. So as software engineers, we're very familiar with different design models in UML, for example, to describe our software system and to do some analysis, or In the case of threat modeling, we have these data flow diagrams to identify security and privacy threats. But our legal stakeholders have quite a different view on the same system, and in many cases, this will be a very elaborate textual description in a Word document, for example. So these are quite completely different views, actually, but they can be about the same system. So the key insight here is that we actually, in our interdisciplinary approach, we actually want to take the benefits of both these perspectives, and we want to see how we can combine this together. So the idea is that we can leverage the existing modeling support, so we can very precisely specify what our data processing operations look like, and we can use a lot of the benefits and techniques from this domain. But of course, for the types of concepts that we need to describe, so what are the key concepts to describe processing operations in a way that makes sense to analyze it from the perspective of the GDPR, you of course need the legal stakeholders to tell us what are what is the precise set of concepts that we need to describe this. And of course, this does not only hold for describing our processing operations, but also for the analysis, as you can see on the bottom side of the slide. So here again, we can use existing techniques such as model queries and analysis, and these allows us to analyze these representations and identify problematic situations in the model. But again, here, the type of assessments that we have to perform, or what such a problematic legal situation looks like, that's again information for which we need our legal stakeholders to tell us how we translate this and what this looks like again, what the problems are that we have to find in these models. So the key thing is that we actually want to combine the benefits of both these views and both these approaches, and we want to use the expertises of both of them together and get the best of both worlds. So that's the key idea of our approach, to combine these two things. So let's have a look at what the key components are in our approach. So there are four main components. So first we have the modeling to describe our processing operations, and we have a number of automated sanity checks to ensure that we have a complete and a precise descriptions. And once we have this representation of our data processing operations, then we can do a number of interesting legal assessments based on these models. In 3 and also in 4, we can provide a number of automated documentation based on these models, because they contain all the information that is needed. So let's first look at the structured modeling. So the next figure will probably be a bit of a scary figure for people who do not have a technical background, but this is the high-level view of our meta model. Now, don't worry if you don't understand the details, because I will have a more accessible and understandable representation of these concepts. But this is just to show you the big picture of the types of different concepts that we offer. And you can also see that there are different relationships between these concepts with some numbers to specify how many elements are linked. And this gives us a very rich way to express this information. So I will illustrate how we can use these concepts in the next 2 slides. So we have 4 main categories of concepts in our model. So the first one is actors and their roles. So we introduce a number of concepts to capture the organizations that are involved in the data processing operations and which legal role they have in that processing operation. So if it's depending on whether it's a controller or a processor, that organization will have different obligations under the GDPR. And of course, in many situations, organizations will rely on, for example, cloud providers to do some of the processing. So it's necessary that we can capture all this information when we are describing our processing operations. Secondly, we have a set of concepts to describe our processing activities. So here we have things like collection and further processing, but we can also make the distinction between several subtypes, such as storage, because if we store information, we also need to specify how long we are storing. For example, there's automated decision making, disclosure. Again, if we disclose information, we also need to say to whom we are disclosing it. So that's again things we can only express if we can make the distinction between these different types of processing operations. So that's why we need to be able to express these elements. Then a third category of concepts that we have are the data types and the data subject types. So these are the actual types of people whose data we are processing, and all the personal data types that we are processing. And of course, we link that to the previous processing activities, so we can describe what data we are processing from a certain type of data subject. And finally, a fourth category is legal rationale, and this is of course also very important in the next part when we are doing some legal assessment, because that relies, of course, strongly on this type of information. So if we process personal data, we always need to specify why we are processing it. So we need to specify a purpose. And of course, we also need a lawful ground when we are collecting data. And consent is, of course, the ones we all know, because we encounter it on every website where they ask our consent. But there are a number of other lawful grounds as well. And these terms are directly from the GDPR. So we can always can also rely on these specific types when we do further legal assessments based on these models. So with this existing set of concepts, we can already describe a number of different situations, but there's a number of automated sanity checks that we can very easily perform by having this underlying meta model that imposes some additional rules. So next I will just give a few brief examples to illustrate to you how we can use these additional rules to allow us to ensure that we have a complete and correct description of our processing operations. So one example is the involvement of actors in the processing. So we can specify that every collection actually must specify a legal role, in this case a controller, as you can see here, and every legal role must also specify the organization that fulfills that legal role. And this allows us to ensure that every processing actually has an organization and a controller linked to that processing, so that ensures that we have this information in the model. Another example is that further processing follows from a collection. So every further processing that we have in our description always has a predecessor, and the only exception to this is a collection itself. A collection itself does not have need to have some further processing before it, and this ensures that we always have a chain, an ordering of our different processing operations, and this also ensures that we always start with the collection up front. So we always need to have an initial collection where we specify what data we collect. This can be both directly from the data subject, but also indirectly if the data is obtained from some other organization, for example. And a final example is that every further processing must have a processing purpose. And this is very important later on to allow us to verify that whatever we do with the data that we collect and we process it further, this must always be compatible with the purpose for which we originally collected the data. So once we have some data, we cannot just do anything with it that we want. We have to make sure that this is compatible with the purpose for which we originally collected the data. So let's have a more detailed look now with these descriptions to the types of legal assessments that we can perform with these models. So I will illustrate this with an example in an existing software system. So this is a patient monitoring system for monitoring patients with cardiovascular diseases. So the idea is that we equip these patients with some sensors to measure, to collect some information about the ECG on their heart and body temperature. And these measures are transferred via smartphone applications to some online system. And this system then collects and stores the data and performs some risk analysis. And that information is then made available to the patient's doctor via an online portal, and that allows the doctor to follow up with the patient and check on the progress of their illness. So what would the processing operations look like? Well, here we can see the four main processing operations. So we have an initial data collection, health risk assessment, storage and archival, and this portal for the doctor to access the information. And here we can apply a quick sanity check. So does every further processing link back? And here we see, because we included these relations, it's very trivial to check that this is the case indeed. Another check is, do we have a controller for every processing activity? Well, we have not specified it here, so we need to provide some additional information. So in this case, we have two organizations, the company that actually hosts this system online, and we have the doctor that follows up with his or her patients. And they are involved both as joint controllers in all these processing operations. So here we have checked the second element too. We can include a lot more information in this model, such as the types of data and the patient type. So all of that is in there, just to show you what we can express, but I will not use all this data in the next example. So the next thing that we have to do is to specify the processing purposes of our different processing operations. So in this case, we would have a contract with the patient to monitor their cardiovascular diseases. So here we include this information in the model. We also have the same purpose for our health risk assessment. And we have a number of additional purposes for the storage and archival and the portal for the doctor. And now we can do one of the most important assessments that we have to do for the GDPR, which is the compatibility assessment. So we have to check that every further processing is compatible with the original collection of the data. Now, in the first case, you see here that we we specified the exact same purpose for the health risk assessment as the one used in the patient data collection. So this check is actually trivial because we have it in a model and we link to the exact same element. So here it's very easy. This is compatible because it's the same purpose. For the other one, of course, here we have longitudinal monitoring. This is a different purpose, and here, of course, we need some input from our lawyer. So that lawyer will do a compatibility assessment and will record the result of this assessment in this compatibility assessment object. And this will specify that the processing purpose longitudinal monitoring is or isn't, depending on the assessment, compatible with that contract and CVD monitoring purpose. And if that's the case, we record that as well in the model, and that way we also know that these processing purposes are compatible. Now, a benefit of this is that we are actually documenting the results of our legal assessments in the model as well. So by just doing this exercise, we can actually later on demonstrate that we are compliant. Furthermore, because we have all this information in the model, if we later make some changes, this can help us to check which elements that we need to revisit. While otherwise, if this is scattered in multiple textual documents, it becomes very complicated to find out which parts that we actually need to reassess, because some of these assessments no longer hold, and which are actually still okay. But in the model, finding these instances is actually quite trivial. So I've just shown you in a brief example how it looks like and how we can perform such an assessment on this system, on this e-health system. Now we did a much more elaborate validation on more extensive scenarios, such as the construction and analysis of the initial description, but we also introduced some extensions such as collecting location information about the patient to be able to notify the emergency services in case of an incident, or storing data in the long term for scientific use. So these are all different types of scenarios to see, can we still express this in the model, and can we further analyze this and make sure that we're still compliant with the different obligations in the GDPR. And as I repeat here, with every change triggers a reassessment and allows us to very easily verify which of our previous assessments that we performed in the past are still valid, and which ones that we will need to redo because we make some changes that invalidated them. And that's very useful, of course, that we can keep track of the progress that we're making, and that we don't have to redo everything when we make certain changes. So with this support, we can do a number of different analysis activities of these models, and this allows us to avoid many common problems. Another easy example is that we need a representative in the EU, for example, if an organization is not established here. So these types of problems are very easily identified in the model. And of course, we have, as I've illustrated in this example, this can assist in performing compliance assessment, because this model helps us to very systematically go over all the elements that we need to consider, and we can keep track of the progress that we're making in performing these different types of assessments. So the next component is the generation of outputs. So besides, of course, our assessments and ensuring that we meet different obligations in GDPR, there are also a number of transparency obligations. So we need to be able to communicate information to data subject, for example. And in meeting these types of obligations, such a model is actually also very useful. So one example that I mentioned in the beginning, the supervisory authorities, if they come asking us to demonstrate our compliance, it's very easy to extract all this documentation from our model. So this is very useful, so we can demonstrate that we are actually compliant with many of these provisions. Similarly, for the data subjects, there's a lot of information that we have to provide to them, such as what data we are processing, what the purposes are, who the responsible organization is. It's all information that we have captured in this model, and that can be very easily extracted. Similarly, for privacy policies, again, such a model can provide support to allow you for writing this information. And these are all different types of audiences, so you don't need to you cannot provide them with the same information. You need to tailor it to these different audiences. But having this single model to extract all this information from prevents you from having to duplicate all this information, and make sure that all of this remains consistent, accurate, and up to date. So it's very useful to reduce some of the effort in being able to provide this documentation. I also hinted when I discussed several of these legal assessments to automation, and that's of course also a key enabler here, is that because of this model, we can automate some of these assessments, and the best way to illustrate this is of course by providing some tool support that can actually do this. So for this, we created data protection modeling framework. So it's a tool that actually allows us to create these different models and guide us in performing these different legal assessments, and allows us to export some of these documentation assets from an existing model. The tool itself is an Eclipse-based product, so we rely on several of these existing components in Eclipse, such as the Eclipse modeling framework and Sirius for our graphical editor. And to perform the assessments and identify problematic situations in the model itself, we rely on model queries and Viatra. So these describe types of situations in the model that we want to find. And we can just query the model to identify and find these elements. And this can also be used to extract a lot of different information for the model, which is of course useful for providing these different types of documentation to different audiences. So next I will show you a brief demonstration of what this looks like. So here we have our data protection modeling framework. I hope that is readable. So this is just a quick example. I will zoom in a bit. What such a model looks like in the tool. So here we have our set of concepts that I discussed earlier. So all these elements are available. You can just drag them on this model as needed to describe these processing operations. And of course, depending on the element that is selected, we can provide some additional information on the organization. For example, we can add information about the address, the country, and this is all information that we can also use when we are exporting documentation. But also, for example, if this organization is established in the EU or not. So depending on whether we add this property, if we then do a quick analysis, we can identify, for example, the problem that this organization is not established in the EU, so we need to add a representative. And just by adding this information in the model, these checks, the result of these checks will change, and this allows us to systematically identify all the problems and improve them and add the necessary information in the model. Of course, other than analysis, there are a number of documentation outputs as well. So I will quickly open a bit larger model just to illustrate this. So we have information about our records of processing activities. So this provides us with an overview for every organizations. We have information about the different processing activities, whether there's a joint controller, what data we process from which data subjects. So it's all information that can very easily be extracted from this model. Also the information that we need to communicate to the data subject, who the responsible controller is, contact information. That's all information in there in the model that we can provide. And finally, we can also generate a DPIA report. And this is, of course, in the current version, this is largely a template, but this gives us actually kind of the framework to further extend and by a lawyer to provide some additional information. But a lot of these different outputs can very easily be generated from this model, which contains most of the information that we need to use. So it's very, it can reduce the effort that we need to spend on creating all these different types of documentation outputs. It can considerably reduce the effort there. Okay. So let's go back to the presentation. So, of course, there's still a lot of work to do and several opportunities to further expand this. One track is to look at mitigations and how do we add more information about different types of legal mitigations in these models. The second track is we see that especially with now the contact tracing apps, that there are a lot of interesting DPIAs being published, and this would of course be an interesting case study to see, to do an in-depth comparison and see whether we can provide a similar coverage based on a description of these contact tracing apps and the associated processing activities in our model, and see whether we can have a similar coverage and amount of details in these as in these published reports. And finally, a third component is risk analysis. So how can we quantify legal risk, and how can we prioritize these different legal compliance problems? That's also a complicated problem of how we can support users in prioritizing these different issues. So hopefully with these illustrations, I've made clear that there are a number of very compelling benefits by relying on a model-based representation of our system to support our compliance assessment. So with that model-based representation, we have our single central source of information that contains all the relevant details and avoids from having multiple duplicated and inconsistent documents describing our data processing operations. We also see that this representation is useful in that we can also document the result of our different compliance assessments in this model. And just by using this, we actually document by design all the information that we need to be able to demonstrate compliance with several of these obligations of the GDPR. And finally, of course, while we make changes and modifications to our model, this tool support and the model representation actually helps us in ensuring that we always have a consistent view on the system, and that we are not, that any legal assessments that we made previously, we can use the model to ensure that that we can find out if these are still valid or not, or whether we need to redo some assessments because of the changes we introduced. So with that, I hope I have shown you that such an interdisciplinary approach is very useful in realizing data protection by design, because we can combine both technical and legal expertise, and both of these are required to meet the obligations laid out in the GDPR. So we can leverage the legal expertise in our set of concepts that we that are available, and make sure that we have a comprehensive and accurate description, while we can use the different software engineering techniques such as our models to guide this assessment and make sure that we can automatically identify many of the problems and help in ensuring that we have a comprehensive and detailed guided assessment of the different obligations. So with that, I want to thank you very much for your attention, and I'm looking forward to the questions.